we're looking at 1.6 Exponential Week 1 assignment in Alex. Today we're just going to be looking at filling in the tables, comparing two different types of functions, and then we're going to talk about our compound interest. All right, so for this first example, the first thing it's asking us to do is fill in the table. We can use our calculators here. So we're just going to fill in 2 to the x power, so 2 to the 6th. It's going to give us 64. 2 to the 7th is going to give us 128. 2 to the 12th is 4096. 2 to the 13th, 8192, and 2 to the 14th is 16384. All right, likewise, this time we're not looking, so no, let me stop here. Notice that this is an exponential function, while this is a quadratic function. What they're asking us to do is we're going to compare the two and see which one grows faster. So 30x squared, so 30 times 6 squared is 1080. So notice early on that the g of x, the quadratic one, is bigger than the exponential. Let's do the next one. So 30 times 7 squared is 1470. 30 times 12 squared is 4320. So still a little bit bigger than the exponential. And then 30 times 13 squared is 5070. So at this point, right, at this point, when x is 13, then the exponential function is bigger than the quadratic, the g of x. And then lastly, 30 times 14 squared is 5880. All right, so looking at the table, so when x is greater than or equal to 13, so we just kind of said that. When x is greater than or equal to 13, so we're looking right here, right? F of x, the exponential function, is what compared to g of x? So in this box, 8,192 is our f of x. 5,070 is our g of x. So f of x is greater than g of x. So all we're doing is using our calculators, we're finding our numbers for our table, filling them in, and then it's going to ask us if f is greater than or equal to this number, then f is what compared to g of x, and just fill in the box. I think there's a pull down menu that you can just fill it in. Excuse me. All right, so now we're getting into the compound interest. Notice that our form here that we're going to use is a little bit complex, but it's not too bad. It's just a different form. It's the same pieces that we're using earlier. It's just in a different, we're adding in the ends. All right, so what compound interest is say you go to the bank and you invest your money in the bank. Certain banks compound their interest at different times. So some of them might do it, now we're talking about this n over here. So some of them might calculate, which is another way of saying compound. They calculate their interest at different times over the course of the year. So semi-annually means that they're going to take however much you have in the bank, and they're going to compound it twice. So let's say they do it once in June and once in December. That means semi-annually, they're going to compound that interest twice. Quarterly means that they're going to do it 4 times a year. So maybe like March, June, September, and December. They might compound your interest 4 times quarterly. Monthly is pretty self-explanatory. They do it once a month. And then daily would be every single day. So over the course of the year, they'd have compounded your interest 365 times. And then all that means is they're just adding on a % each time they calculate. All right, the t is still the years, and then the rate, we're still using decimals. So let's go ahead and find the answer to this problem. It's saying, suppose you invest $2,000 at 4.9% compounded, and then we should underline this, semi-annually, right? That's giving us our hint to our n. Then it's saying, find the amount after 9 years. Okay, so let's go ahead and fill all this information in that they're giving us, because it's kind of a lot. All right, so we know our n, because it says semi-annually, is going to be twice. We also know that our rate in decimal form, well, let's just move our decimal point over, so that our rate is 0.049. And then our time, it's saying, is in 9 years, so t is 9. We have all this information. We're just going to fill it into our equation. So we're going to have y equals, the initial amount is $2,000. We're investing $2,000 today. We have 1 plus, our rate is 0.049 as a decimal. The number of times n, they're compounding every year, is twice. We know that because it's semi-annually. Now notice again, we have our t here again. So we have 2 times, our time is 9 years. So if we can punch this into our calculator just as we wrote it down, which you can if you use Google Calculator, or if you use a graphing calculator, a scientific calculator, you should be all right. Be careful if you're using iPhone. iPhone doesn't do order of operations very well, so you're gonna have to do it with a bunch of parentheses in there. But if we calculate this, 2,000 parentheses 1 plus 0.049 divided by 2, close our parentheses, and then raise it to the 2 times 9. Then we end up with, oops, I should probably say, y is approximately equal to, right, the squiggly lines, because we're going to round here, $3,092.04. Okay, so the way that banks work now, you're not going to get a 4.9% interest rate at any bank. But if you invest your money wisely, there's ways to get about 4%. You'd have to go ask a financial advisor where you want to invest your money. But yeah, in 9 years, your $2,000 would have become $3,092.04, which is kind of good, considering that you didn't do anything. You just left it in the bank, and then that's the amount of money you end up with, right? So when you're starting off work, when you're still young, it's a good idea, even though you might not be thinking about retirement, to start a retirement fund, because the more money you put in, let's say this is the exponential growth, right? We know that it looks kind of like this. If you start investing here when you're 18 years old, it's gonna hit this exponential part where it's growing super fast earlier in your life, so that when you retire, you can maximize your amount. Now, if you start when you're older, say you're doing it when you're 30, right? By the time you retire here, right? So let's say this is when you're 60 and you want to retire. When you're 60, you're still going to be on that small part of the curve, so you're going to have to invest a lot more money up front to end up with the same amount of money at the end. So something for you guys to research, something for you guys to look into. There's a way that you can definitely become millionaires by the time you retire, but you gotta start investing your money early and invest it wisely, and make sure you do it that way. So that's really all that we have for this one. We're just looking at the table. We're trying to compare growth rates between different types of functions in that first example. And then the second example, we're going to be doing a compound interest. Just be careful that we fill in our numbers in the proper places. Again, make sure that we convert any percentages to decimals, and we use the proper ends, right, depending on how we're compounding our interest given from our problem, and then we should be okay. All right, make sure you have your notes. Make sure you bring any questions next class so we can work it through. Good job again today. I'll see you next time.